Hello students, so we will start with our next lecture, that is mechanical properties of fluid. Okay, chapter wise discussion of JEE Main 2025 January attempt. So let's see the first question. So we have our first question here, this one. Okay, two soap bubbles of radius 2 centimeter and 4 centimeter respectively are in contact with each other. The radius of curvature of the common surface in centimeter is. See, the question is like this. This will be one bubble, okay, and there will be another bubble. You didn't merge it together, you just kept in contact. Then what is this common radius? Okay, actually this will be like this. This will be like this. Okay, what is this common radius? This r he is asking. Okay, so this exact calculation is done in the notes. Start from inside this side, pressure p naught, increment in the pressure. From here, increment in the pressure. This is 4t by r. Okay, by that calculation you will get r is equals to this, like this. 1 by r is equals to 1 by r1 minus 1 by r2. This relation comes. Okay, how this relation comes exactly you know in the notes. This is the question. There was a question exactly in the notes. So r is equals to r1 r2 divided by r2 minus r1. So here these are 2 4 given, 2 4 divided by 4 minus 2. So this came how much? 4 only, 4 centimeters. That's it. Notes based question, directly answer. See, so answer is your 4 centimeter. Okay, in centimeter only. So 4 is your numerical answer that you have to fill. Next, a small rigid spherical ball of capital M is dropped in a long vertical tube containing glycerine. Okay, the velocity of the ball becomes constant after some time, means terminal velocity, right? If the density of the glycerine is half the density of the ball, then the viscous force acting on the ball will be, okay, density of the glycerine is half of the density of the ball. Density of glycerine is half of the density of the ball. Okay, so what he is saying is basically how much is the amount of viscous force he is saying. Okay, viscous force acting on the ball will be, okay, so on the ball there is an mg. Okay, this mg you can write as density of the ball into volume into g also, right? Okay, and there will be a buoyancy. Buoyancy will be how much? Buoyancy you can write down density of the glycerine into volume into g. Okay, if density of ball, see, if density of glycerine, so if you put glycerine, this is density of ball. So here what can I write down about this buoyancy force? Density of glycerine, I can write down density of ball by 2. So 1 by 2 times of density of ball into volume into g. So it is completely inside, so volume is also equal. So this is equals to mg, so this is mg by 2. Okay, buoyancy force is mg by 2. Okay, and this is gravitational pull. Okay, now you said that net force is 0, means there is a viscous force acting at this point. Okay, what is the value of viscous force? Just balance the forces, that's it. So I can say upward force is mg by 2, buoyancy force plus viscous force is equals to downward mg. Okay, that's it. So F viscous came how much? Mg by 2. Okay, it is equivalent to mg by 2. That's it. By this relation only. Okay, this is, I will not say hard question, but this is good question. Okay, so here maybe like here if you put the density different, then answer can come different. That's all. Okay, so you have to remember the how you are writing this thing. Okay, so just this is the buoyancy value. Then this relation, you know, by relation you go, then you can find out that the buoyancy force is equals to half of the gravitational pull. Okay, so half is the buoyancy is balancing, so half have to balance by viscous force to get the net force 0, because when he is reaching the terminal velocity, the net force on the body will be 0. Okay, that's how. So this mg by 2, so your answer is fourth option. Okay, next question. See, this is exact notes question. Okay, I think A and B as radius we took, okay, in the notes. So a tube of length L is shown in the figure. A radius of cross section of point 1 is 2 centimeter and point 2 is 1 centimeter respectively. If the velocity of the water entering the point 1 is 2 meter per second, then the velocity of the water leaving the point 2 will be. What is the formula? A1 V1 equals to A2 V2. How this formula comes? From the conservation of mass. Okay, density is same, so conservation of volume, whatever you want to say. Okay, so area is what? Pi r square 2 square centimeter only, because here also centimeter we are going to put. So velocity is given how much? 2 meter per second. So 2 is equals to pi into 1 square into V2. That V2 only is asking. So V2 will be how much? 8 meter per second. That's it. 8 meter per second. Option number 4 is your answer. Okay. Now see the next question. Next, he is saying a tube of length 1 meter is filled completely with an ideal liquid of mass 2m. Okay. Here see mass is 2m. This is one mistake you can make. Remember. And closed at both ends. Okay. The tube is rotated uniformly in horizontal plane about one of its end. If the force exerted by the liquid at the other end is F, then the angular velocity of the tube is. Okay. If you see in the notes, we have done one question where we have this is like this, rotating with a constant angular velocity. Okay. And there was a fluid in this tube of length L, let's say. He said 1 meter, I think, right? But let's take L. Okay. We'll solve this. Then he is asking what is the force here he experienced. Obviously here the force will be 0, right? At this edge, force 0. Okay. So we solved for particular x1 and x2 also. Okay. But from here to here, if I am going to do, then I can solve for that also. See how. What you do at x distance, I am doing a proper integration. Okay. If you don't, because in JEE we don't go for the formula, we go for the concept, right? So for all the formulas we never emphasize to remember, right? But those formulas are continuously repeating, and basic formulas, that's we remember, right? But this is not the very basic formula, so that's why no need to remember. You can always solve. At x distance, what you do, you assume a dx slit. Okay. Okay. You assume that dx slit. So in dx slit there will be a dm mass is there, right? So what is the dm mass? The dm mass will be how much? Okay, dm mass I can write down density into, so area of cross section assuming A. Okay, what can I say about the dm mass? Mass is what? Density into volume. Volume is what? Dx into A into dx. This is my dm mass, right? And this dm mass is rotating with a omega, right? Every whole mass is rotating with omega only, right? So I can say that mr, this m is what? Dm mass, right? Dm mass is rotating in a r radius, that is x. Okay, x radius. Okay, into omega square, mx omega square. Okay, this is what he is rotating in. Is equals to, who is providing the net force on this body? So basically there is a force difference here. From here onwards there is a force increment, right? So there will be a force from this side F1 and from this side F2. Okay, these are like this force will be there. So I can say net force on this part, right? So that F will be there. Understood? On this part there will be a F. Okay. Integrate this. Now from where to where, from which difference of forces you want to find out? You want to find out from initial to final, because initially you know this is 0, right? Here the particle is not rotating, it is stationary. Okay, so here that is 0. Okay, he is not rotating, right? So nothing, omega 0 for this particle. So this is F0, this is F force. So directly separation, this F value directly is your answer. Okay, this is only your F he mentioned in the question. Here he mentioned F force. Okay, but one thing you remember, this dm mass when you will integrate, you will get 2m. Here density when you will write down, density will be what? Density is what? Density when you will write down, this will be mass 2m divided by volume. Volume is how much? Volume is your area into length. Okay, A into L. Okay, so dm if you integrate, x dx is there, right? So I can say omega square is constant outside. Okay, and rho is constant, A is constant outside. So you have x dx is equals to F. X dx integration, x is going from 0 to L. Omega square, density value you put 2m by A into L into A, and x dx, x square by 2 means L square by 2. Okay, L square by 2 is equals to F. Okay, this is what the value is. Okay, so now from here area got cancelled out, 1 L got cancelled out, 1 2 got cancelled out. Okay, and you have what? Just you have m and L. So omega is equals to under root F by ml. Okay, under root f by ml. Okay, so L is given 1, so you put that value also. So L you will put 1, then alpha will come what? There is no constant inside, right? So I can say alpha is 1. That's it. So my answer is alpha is 1. So question number 4 answer is 1. Okay, that's it. Understood na? Here alpha, L value you can put 1, and then there he's mentioning that there is an alpha. So alpha constant 1 only, right? That's it. So my answer is 1. Question number 5, right? See the question. So generally what happens now, students have that habit that there should be a constant, there something should come, 2, 4, so they just think again. Okay, obviously in the paper, as I told strategy, if you see first lecture of mine, strategy for JEE Main, then I told you that spend some 15 second more to recheck the answer. Okay, because we are putting lots of effort in doing this question. So if we spend 10-15 second more, then it will be beneficial for us only, right? That's why. So it's better to spend, but I'm saying that alpha can come 1 also. Okay, that's not a problem, because here there is a 1 chance of mistake, that this 2m, if you put here density as m by al, then answer will come something else. Okay, then that should not happen. That is a wrong. See next, accession and reasoning. Assess statement 1, statement 2. So statement 1 is saying the hot water flows faster than the cold water, and the statement 2 is soap water has higher surface tension as compared to fresh water. Okay, so hot water flows faster than the cold water. Okay, so this is surface tension viscosity comparison. Okay, so see, viscosity, we say for liquid changing the viscosity is different, and for the gaseous how viscosity changes, that is different. Okay, so for liquid we say, for liquid, this I tell you here only, for liquid we say that as temperature increases, okay, viscosity will reduce. Okay, why? Because intermolecular forces decreases. Okay, as your temperature increasing, the intermolecular forces, they are going away and away, right, from each other. They are getting higher velocities, so viscosity will reduce. Okay, so here only that statement, the hot water flows faster, because in the hot water viscosity is less. So it is less viscous. Less viscous means easily flowing. Okay, that's why hot water will flow easily. Okay, that statement is correct. Soap water has higher surface tension as compared to fresh water. No, soap water is surfactant, right? So for the soap water, the surface tension is lower. Okay, so soap is added to the water for lowering the surface tension. Understood? So this statement is false. So first statement is true, second statement is false. Okay, so your answer is option number 1. Okay, that's how. Next, see, water flows in horizontal pipe whose one end is closed with a valve. Okay, the reading of the pressure attached to the pipe is P1. Okay, the gauge pressure is coming P1. The reading of the pressure gauge falls to P2 when the valve is opened. The speed of water flow in the pipe is proportional to. Okay, so basically saying before opening means inside pressure is P1 and outside pressure is P2. Okay, right? So basically after opening you came out, you are applying the Bernoulli's equation outside the pipe, right? So what you will say, you apply the Bernoulli's equation. So inside the pipe water is stationary, right? Is not going anywhere. So I can say, and at the same horizontal level everything. So pressure P1 plus then rho g h same. Okay, potential, and we say kinetic energy is also 0 because it's stationary. Finally is what? P2 plus half rho v square, right? So from here what we can say, v will come proportional to under root P1 minus P2. That's it. Okay, the Bernoulli's equation you have to think. Okay, so this is your fourth option, your answer. Okay, by Bernoulli's equation you have to answer this question. Okay. See, here he is saying in a horizontal pipe. So horizontal pipe means rho gh same. Okay, then he is saying reading attached to the pipe is P1. Okay, so closed valve means nothing is flowing, right? So then it is P1. When you open, it is P2. Okay, that's how. Sixth, seventh. An air bubble of radius 1 millimeter is observed at a depth of 20 centimeter below the free surface of liquid having surface tension 0.095 joule per meter square. density is given, the difference between the pressure inside the bubble and atmospheric pressure is, okay. So depth is also there, so it is like this. This is liquid and this is the bubble here, right? So here is P naught when you came down. So P naught plus rho GH, here is what is the pressure? P naught plus rho GH. When you went inside, so what is the pressure? This is the bubble, but this is inside the water. So increment is 2T by R. This is bubble, but there is a one layer only you are crossing, right? So 2T by R only. So inside pressure is P naught plus rho GH plus 2T by R. Okay, this is one mistake you can make. Now he is asking difference between this. So subtract the P naught. So your answer will be calculate the value of rho GH plus 2T by R. That's your answer. Okay. So put the values. Density 10 to the power 3. GH is what? 20 centimeter. Okay. So density 10 to the power 3 into G into 20 centimeter means what? 20 by 100 plus 2 into surface tension value is also given 0.095. Okay, means 95 into 10 to the power 3 minus 3 divided by R. R is how much? R is given 1 millimeter. 1 millimeter means what? In meter if you answer 10 to the power minus 3. Okay. So from here if I get my answer, so 2000, okay, plus here how much? This is 95 into 2. So how much this is? 190, right? 190. So this is 2190. Okay, 2190. So that's my answer. The atmospheric pressure, pressure only is asking. So 2190. That's my answer. Okay. Right. Next. Question number 8. The amount of work done to break a big water drop of radius R into 27 small drops of equal radius is 10 joule. Okay. Now if you remember in the notes we have solved, okay, when you break the one water drop into n number of water drops. This lecture I have recorded on the YouTube also of surface tension. There I discussed this thing. Okay. So there we calculated the work done that is required or energy absorbed, energy required, whatever in terms you say. That comes to be surface tension 4 pi r square. This r is mean radius of the bubble. Okay, into n raised to power 1 by 3 minus 1. Okay. How we calculated this value? Surface tension into final total surface area minus initial total surface area. And how is the relation came between the radiuses? By the equating the volume. Okay. So from there we got this formula, right? Now in the first part he is saying this value is 10 joule. Okay, when the 27 droplets are there. Okay. So one he is saying that work done is equals to T into 4 pi r square into, he did 27, okay, 27 small drops. So 27 raised to power 1 by 3. So 3, right? 3 minus 1, 2. That's it. And this is 10 joule, okay. Then he's saying some W into T into 2 pi r, 4 pi r square into, then what he is saying, now he did 64. 64 means what? 4, right? So 64 raised to power 1 by 3, 4. 4 minus 1, 3. That's it. So W value how much came? 10 into 3 by 2. Okay, so this is 15 joule. That's it. By one formula answer. Notes formula this is. Okay, nothing is special. Notes formula. Okay, so the 15 joule means option 1 is your answer. Okay. Next. Question number 9. The air bubble of radius 0.1 centimeter lies at a depth of 20 centimeter below the free surface of the liquid density 10 to the power 3. If the pressure inside the bubble is 2100 Newton per meter square greater than the atmospheric pressure, okay, then the surface tension of the liquid. So this is same as this question. Okay, same as this question. He gave the surface tension value and he asked the pressure. Okay, and here what he did? Here he gave the pressure value and he asked the surface tension. So get the answer. So what we can see, we'll say again that same thing, that rho GH plus 2T by R is equals to what? Pressure. right? So that pressure given 2100. So rho gh, so density 10 to the power 3, rho g is given 10, h is given 20 centimeters, same 20 centimeters. So 10 to the power 3, so g 10 to the power 4 into h is how much? 20 centimeters. So 20 by 100 in meter plus 2 into t divided by r. Okay. So here see this answer are half of each other, right? So maybe if you put 40 by r, then answer will come wrong. Okay. 40 by r. R is given how much? 0.1 centimeter. So 0.1 centimeter if you put in meter, then what you will get? 0.1, and if meter, then 100, right? So 100 here. This is equals to 2100. Understood? So from here, if I get, so what can I say? 10 is to power 3, okay, and this will be 10 is to power 3 again here, okay. So 10 is to power 3 common, so hold on, 2t here, 2000 plus this is 2000t is equals to 2100, okay. So 2000, okay. T is equals to how much? 2000. If we go that side, we will have 21 by 20 minus 1, right? Yeah. So this is 1 by 20. Okay, so 1 by 20 means how much? 1 by 20 means how much? Multiply by 100 divided by 100. 0.05. Okay, that's it. So 0.05, option number 2. So ninth option number 2. Okay, that's it. Next, if you have took 40 by r, then I think which option will match? Don't know, leave it. Question number 10. In the experiment for the measurement of viscosity, okay, of given liquid with a ball having radius r, consider following statement. Okay, some a b c d statements are given and we have to identify which are correct or which are wrong. Okay, this is the question. So statement a is saying graph between terminal velocity and radius r will be a parabola. Okay, so we know terminal velocity and radius of the ball, what is the relation? We know v is equals to what? 2 by 9 density of the ball minus density of the medium, okay, multiply by r square g by eta. Okay, so velocity and r relation is parabolic only, right? So this is correct. So a statement is correct, means either was first option or either third option. Okay, then come to the b. The terminal velocity of different diameter balls are constant for a given liquid. Terminal velocity of different for a constant. No, this will be not okay. Why? Because terminal velocity is dependent upon the radius, right? So diameter of the balls is changing. Okay, terminal velocity of different diameter balls. Okay, if diameter you are changing means you are changing the radius, right? If you are changing the radius, that means terminal velocity will change. Okay, then statement C. So obviously B is correct, B is wrong, right? And A is correct. So A is correct, this two option, and B is wrong means third option. So I can say 10th answer is third option directly. Okay, but still let's see the C. Measurement of terminal velocity is dependent upon the temperature. Yes, because terminal velocity is dependent upon viscosity and viscosity is dependent upon temperature, right? That's why. Now see D. D, we can say this experiment can be utilized to access the density of the given liquid. Yes, because in the formula density of the liquid is coming, right? So if you have the other parameters, you can find out the density of the liquid, right? And the next thing, E part, if balls are dropped with some initial speed, the value of eta will change. No, eta is the property of the liquid, right? So why it will change if you are dropping with some initial velocity, right? Okay, so what we can say, E statement is wrong. Okay, so option is third answer. Next, same thing, statements are different. Okay, so he's saying, if you see here, there is a pattern. Okay, all the questions which you are discussing from different shifts, right? But the question level, everything is same almost, right? That means if the previous paper question you know, then you can expect that this kind of question, this level of question can be asked from this particular topic. It can be asked, right? So you can revise also that particular topic. Okay. So statement. So A is what he is saying. Surface tension arises due to extra energy of the molecule at the interior as compared to the molecules at the surface of the liquid. Actually, it is opposite. Okay. On the surface, there is a higher potential energy. That's why there is a surface tension, right? So A statement is wrong. So A is wrong means that two option went. Okay. These two are possible. Now let's go for the B. Because see here, many statements are there. If I am clear with one or two statements even, I will get the answer. See how? B option, what he is saying? B, as the temperature of the liquid rises, the coefficient of viscosity increases. He is talking about the liquid. Okay. So as temperature will increase, viscosity will reduce. Okay, because intermolecular forces are reducing, right? So viscosity will reduce. So this B also wrong. So answer is first option. That's it. What I got? First option answer. 11th question. Okay. But let's see ahead also. Okay. C statement, he is saying as the temperature of the gas increases. Okay. Now he is talking about the gas. Okay. As the temperature of the gas increases, the coefficient of viscosity increases. Yes. For the gas, as the temperature increases, viscosity increases. Why? Because velocity of the molecules will increase. Okay. When the velocity of molecules will increase, they will be high viscous. Okay. That's how. But in the liquid, as the temperature increases, intermolecular forces decreases. Okay. That's why there is a decrement in the viscosity. So these are two different things. They goes opposite to each other. If you remember one, you remember for the liquid. Okay. As it goes for the intermolecular forces, automatically it will come for the gas also. You will able to remember because it is opposite. D, the onset of turbulence is determined by the Reynolds number. Yes. Okay. So that is true. Okay, Reynolds number you can determine that what is it is a steady flow or turbulent flow, right? Okay. So E part, in a steady flow, two streams lines never intersect. True, right? This is we wrote in the start of the fluid mechanics only, that how the streamline flow and everything we wrote. Okay, about theoretical part discussion. Okay. So E is also true. So option is first one. Understood? Next question, 12th. A 400 gram solid cube having edge of length 10 cm floats in water. How much volume of the cube is outside of the water? Basic question of fluid mechanics is asking. A cube, okay, mass is given m, okay. How much is the outside? This x. So this is how much? 10 minus x, okay. So for inside you will apply the buoyancy. Buoyancy is what? Or you name it y, okay. So what is the buoyancy? This, if you assume this is 10 square, right? So buoyancy is density of the liquid into volume inside the liquid. So volume is how much? 10 square, so centimeter this is, right? Centimeter you get in the meter. So 10, so 1 by 10. 1 by 10 square into y. This is volume inside into g is equals to mg. So mg is how much? 400 into g. 400 into g. So this is 10 to the power 3 also. Okay, in kg. Everything I will deal in SI unit. Density is given 10 to the power 3. Fine. Density is 10 to the power 3. Okay. So from here, if you see here, g got cancelled out. Okay, and 10 to the power 3, 3, 1 by 2 square, power got gone 1 here out. Okay, so y is equals to what? 40 divided by 10 to the power 3. So this is how much? 4 upon 10 square. Okay, so y is how much in centimeter? If I talk, this is in meter, right? Centimeter, this is 4 centimeter. So outside is how much? 6 centimeter, because total is 10 centimeter. That's it. So answer is 6 centimeter. Outside is 6 centimeter. So volume is asking outside. Okay. So 6 and length and width is how much? 10, 10, right? So 600. So answer is your second option. So 12th answer is second option. Okay. Now let's see next question. Next part is saying, in a hydraulic lift, the surface area of the input piston is 6 centimeter square and that of the output piston is 1500 centimeter square. If 100 Newton force is applied to the impact piston to raise the output piston by 20 centimeter, then the work done is. So basically, force you calculate for the output piston multiply by the distance travel, that is 20 centimeter. That's your work done. Okay. So we know in hydraulic lift, pressure is how much? Same, right? By the Pascal's law. So we say F by A, F1 A1 equals to F2 A2, right? Equating the pressure. Okay. So what is the forces? So I can say area is given, here area is given, and for the smaller one, we gave the 100, right? So 100 Newton force on 6 centimeter square, then F2, you are getting something, area is 1500, okay? 1500 centimeter square, correct? Okay, so F2 you will get how much? This is 15 into 10 is to power 4 by 6, okay? This is your force. Force work done will be how much? Work done is basically force into displacement, okay? So force is how much? 15 into 10 is to power 4 divided by 6 into distance, that is 20 centimeter, right? Yes, yes, 20 centimeter. He is asking in kilojoules. So let's convert that also. Kilojoules means what? Let's first get the answer. 0, 0 cancel out, 10 is to power 3, leave it as it is. This is 3, this is 5. So 5 into 10 is to power 3, okay? 5 into 10 is to power 3 means 5 kilojoule, okay? So answer is, so what is your answer? 14th question answer is 5 kilojoule, okay? So that's how your questions of this fluid mechanics, all are formula based questions from the notes, okay? Nothing goes out of notes in JEE Main, okay? Easy to crack, obviously. Understood? So that's how the questions are. Thank you.